Hello everyone, welcome back to this online class. Today I want us to look at how to integrate tan x raised to 7 with respect to x, or simply tan raised to 7 of x dx. So to be able to evaluate this kind of integral, there are two methods. The first method, we are going to be using the identity that 1 plus tan squared x is the same as sec squared x. So we use that identity so that we can rewrite our integrand. So take note that tan raised to 7 of x is the same as tan x times tan raised to 6 of x, which you can as well write as tan x in bracket tan squared of x, and this is cubed. Now we need to replace tan squared x. Tan squared x, you can find it from this identity that 1 plus tan squared x is equals to sec squared x. So when you make tan squared x the subject, you get tan squared x is equals to sec squared x minus 1. So from here, tan squared x is equals to sec squared x, then you subtract 1. So we are going to replace it here, replace for tan squared x in that equation, so that we'll get tan x in bracket 1 minus, not 1, but it should be sec squared x minus 1. Let me wrap this. So that should be sec squared x minus 1. And this is supposed to be cubed. So now let's go back to our integral. So you can now say, therefore, the integral of tan raised to 7 of x dx is the same as writing the integral of sec cubed of sec squared. Let me change that. Integral of sec squared of x minus 1. This is supposed to be cubed times tan x dx. Now, the next step is to use u substitution. So we are going to say let u be equal to sec x. Let u be equal to sec x. So when you differentiate that one, remember the derivative of sec gives you sec tan. So therefore, du dx, that will give us sec x times tan x. Remember this dx, du dx. When you multiply, you get times dx. So I can make, let's make this the subject, tan x dx. What is that? So from here, we see that tan x dx is the same as du over sec x. But what is sec x? That is the same as u. So this can be written as du over u. Now let's go back to our integral on the right hand side. If we replace sec x by u and also tan x dx by du over u, this integral will now become, so this integral will now be equal to the integral of u squared minus 1 that is supposed to be cubed times du over u. We are replacing the whole of tan x dx. So let us cube this one by binomial expansion. So that's the same as the integral. When I cube it, remember, take note that a minus b cubed is the same as a cubed minus 3a squared b plus 3ab squared, then minus b cubed. So we are using this expansion. Take note. That's what we are using. So to expand this, it will be u squared, then you cube it. So that will give us, let me pick a different color. That will give us u raised to 6. Then minus 3a squared b. So that's minus 3 a squared. When you square u squared, you get u raised to 4. Then times b. Our b is 1. So this will give us u raised to 4. Then there's plus 3 u squared. Because our b is 1. 1 squared is just 1. Then minus b cubed, which is 1 cubed. That is 1. Times du over u. I can divide this by u so that this can be written as, when I divide by u, it is the same as u raised to 6 minus 3 u raised to 4 plus 3 u squared minus 1, everything over u, and then du, of which, if you simplify, you're going to get the integral of u raised to 5 minus 3u cubed plus 3u minus 1 over u. And this you need to integrate with respect to u. So when you work it out, this should give us 1 over 6 u raised to 6 minus 3 over 4 u raised to 4. We are using power rule, plus 3 over 2 u squared minus ln of u plus a constant c. So that is our solution, but we have to replace u. Remember, we said u is equals to sec x. So let us replace u by sec x. So this can now be written as 1 over 6 sec raised to 6 of x minus 3 over 4 sec raised to 4 of x plus 3 over 2 sec raised to 2 of x minus ln of sec x, then plus a constant c. So that is the integral of tan raised to 7 of x when we use the first method. There's another method. Let us call it method 2. I'll write it here. In method 2, what are we supposed to do? We are going to again to rewrite our integrand, tan raised to 7 of x. How else can it be written? So you take note that tan raised to 7 of x is the same as tan raised to 6 of x times tan x. I'm breaking it down into product of those two functions. But what is tan raised to 6? Instead of this one, let me use, because this can also be written as, instead of having tan raised to 6 of x times tan x, we can have this as tan squared x times tan raised to 5 of x. Still the same. I want to replace tan squared x. We know tan squared x, so this is the same as 1, not 1, we said tan squared x is the same as sec squared x minus 1. So this is the same as sec squared x minus 1. That is tan squared x, then times tan raised to 5 of x. Which you can, if you open the bracket, this is the same as writing, it means a different color. It's the same as writing sec squared of x times tan raised to 5 of x minus tan raised to 5 of x. Now, I need to know what is this tan raised to 5 of x. I need to replace, let me underline it. I need to replace this again. So we need to know what is that. So again, we can write that tan raised to 5 of x, this can also be written as tan squared x times tan cubed x. But what is tan squared x? Tan squared x is the same as sec squared x minus 1. Then we are multiplying by tan cubed x. If I open the bracket again here, we are going to get, let me pick another color. We are going to get sec squared of x times tan cubed x plus, not plus, that should be a minus, minus tan, let me wrap this, so that we write minus tan cubed x. Again, I need to know what is tan cubed x. So we write tan cubed x is the same as tan squared x times tan x. But what is tan squared x? Is the same as 1 minus sec, not 1 minus, it's the other way around. So tan squared x is the same as, I can use a different color, is the same as sec squared x minus 1. Then we are multiplying by tan x. Again, if I open the bracket, I'm going to get sec squared x times tan x minus tan x. So now that we know tan raised to 7 of x, tan raised to 5 of x, and tan raised to 3 of x, we now perform what is called back substitution, so that we go back to where we started. We started with tan raised to 7 of x. So by back substitution, this is what you're going to get. Back substitution means that the value that you have found as tan cubed x, you substitute here. Then the value you have found at tan raised to 5x, you substitute here, so that you get tan raised to 7x. So let's substitute tan cubed x into the answer for tan raised to 5 of x. What are we supposed to get? So we write here back substitution. Back substitution will give us this one, tan raised to 5 of x is equals to sec squared of x times tan cubed x minus tan cubed x, but we know tan cubed x to be equal to this one, the whole of this. So this is what I'm going to write in place of the other tan cubed x. So that's the same as minus the whole of that, so it's minus sec squared x tan x. A minus and a minus will become a plus, so plus tan x. And then again, we substitute this value of tan raised to 5 of x into our expression for tan raised to 7 of x. So still back substitution, tan raised to 7 of x will be equal to sec squared of x times tan raised to 5 of x. I replace this other tan raised to 5 of x by this value, the whole of that. So it's a minus of that, the whole of this expression. So minus sec squared of x tan cubed of x. This would now be a plus sec squared of x tan x minus tan x. So you see, you can see sec squared of x is common in the first 3 terms. That one can be factored out. So we can say this can further be written as, let me pick a different color. This can further be written as tan raised to 5 of x minus tan cubed of x. Then there's a plus tan x. And you can see sec squared of x is common. So that is factored out. Then I can see there was another minus tan. That is the expression for tan raised to 7 of x. So that's what you need to integrate. It's now easy to integrate the way it is. So therefore, the integral of tan raised to 7 of x dx is the same as the integral of tan raised to 5 of x minus tan cubed x plus tan x. The whole of this in bracket times sec squared x dx minus the integral of tan x dx. I'll just split that into 2 integrals because of the linearity property of the integral. So let's look at the first integral. We are going to use u substitution. In the first integral, you let u be equal to tan x. So with that substitution, it means that du is the same as sec squared x dx. That is in the first integral. What about the second integral? Second integral, you need to rewrite tan x as is the same as the integral of sin x over cos x dx. That is tan x, so minus that. So if I now substitute, you're going to get this. You're going to get the integral of u raised to 5 minus u cubed plus u du. The whole of sec squared x dx, that is the same as du. Then the other one is minus the integral of sin x over cos x dx. In the first integral, use power rule. So this will give us 1 over 6 u raised to 6 minus 1 over 4 u raised to 4 plus 1 over 2 u squared minus, simply this will be a plus because I could take this, let it be positive and this is negative. When you let u be cos x, du will be negative sin x dx. So that's like integrating 1 over u. du. So that's a plus ln of cos x. Then there's a constant c of integration. Now let's replace u. Our u in this case is tan x. So when you replace u by tan x, you're going to get your final answer to be 1/6 tan raised to 6 of x minus 1/4 tan raised to 4 of x plus 1/2 tan squared of x plus ln of cos x plus a constant c. So when we use method 2, look at our answer. Let me circle these answers. You realize that we get our integral, or simply our answer, in terms of tan x and cos x. Look at the answer we got in method number 1. Let me go back. This is what we got. It was in terms of sec x only. And you need to show that the answer we have in part 1 is the same as the answer we have in part 2. To try that, pick an arbitrary angle. Let's say work with 30 degrees. Let x be 30 degrees and substitute it here in the answer we have found in part 1. Do the same to the answer that we have found in part 2. This one, method 2, you'll realize that whatever you get when you substitute x is equals to any angle 30 degrees, whichever angle that you pick, you're going to get the same result. And so that tells you that those answers are identically the same. They are similar. They're the same expressions, same answers. So thank you all for watching. Please subscribe to my channel. That is Professor Francis Okech. Also like, share, and comment on my videos. Next time when we meet, we look at other integrals involving trigonometric functions. Bye-bye.